2-bit arbitrary counter continuation. Develop excitation equations for F logic. Next state is 2 equal to present state 2, present state 1, present state 0. And then one question. Here is present state bar. So multiplication of these, we will get next state 2. Or NS1, next state 1, PS2 bar into PS1 X naught with PS0. Then you will get NS1, next state 1. For next state 0, PS2 bar and PS2 0 multiply, then we will get next state 0. So we will get excitation equations for F logic. NS0, next state 0, next state 1, next state 2. Develop excitation equations for Y. First we made for F. Now Y output. So Y1 output and Y0 output. Okay. For this here K-map. Here one combination. Here one combination. And then here one. Here one. Here one. And here one. Excitation equations for H logic. F logic finish. We have seen Y0, Y1 output got, and then now for H logic. For H logic, Y1 equal to PS2 bar present state bar 2 present state 2 bar into present state 1 bar plus present state 0 bar plus present state 1 bar plus into present state 0 bar. Then we will get Y1 output 1 Y1. For Y0 output Y0 equal to PS bar present state 2 bar into multiply with PS present state 1 plus PS present state PS0 present state 0 bar. That is here OR gate. After this not AND gate. Like this here also AND gate. Here OR gate. Then work AND gate with this OR gate. Recall Moore FSM. Recall Moore FSM. Finite state machine. Recall Moore finite state machine. Input vector X. Okay. Combinational logic F logic. Next state. Okay. Register. For this register clock signal. For reset for this register here bubbles. And then here after this register present state here. From this present state negative feedback connecting to again combinational logic F. After PS present state, this one will connect to H logic combinational circuit. This combinational circuit output will be Y output vector. This is the feedback path we already have seen. So totally we can say sequential circuit, but this is combinational circuit, this is combinational circuit. Okay, two combinations. Okay, state equations. NS state equations. Next state. Next state. NS. Next state equal to what here coming? This function coming, no? Here what will go doing process, this will come out. Am I correct? So what function? Input vector already we have seen. And then this negative feedback, no? PS. Here PS coming, no? This PS also here coming. So this PS here. Present state. So next state equal to function of S comma PS present state. Next state equal to function of input vector comma present state. That is present state will present before from combination logic H. That combination logic H only computating for output vector. Okay, no? Y equal to, that is output vector equal to H equal to what function going on here? PS. That is PS. What I said now. PS present state. Present state with this logic. PS only here coming. That PS output only here coming. So Y equal to H of H means H combination circuit. H logic. Yes. Present state. Logic circuit for this. So this is full F logic. Sorry. This is full F logic. F logic. This is F logic. In F logic, what we have? NOT gate, NOT gate, NOT gate, yeah. AND gate, exclusive NOR gate, NOT gate, okay, register, D flip flop 1, 2, 3, here reset, clock pulse here, early, all reset, here, this clock given to each flip flop. This H flip flop, sorry, H logic. Here is Y vector output. Okay. Here NOT gate, NAND gate. Sorry. No, exclusive NOT gate. Here AND gate, OR gate, AND gate, NAND gate. This NOT gate only. Exclusive NOT. Okay. Not OR gate, NOT gate. Connection for you. This is our what? Present state. Okay. Let's see. So what is this? Logic circuit. Correct. So for this circuit simulation, 200 nanosecond. 400 nanosecond, 600 nanosecond, 800 nanosecond, 1 microsecond, 1.2 microsecond, 1.4 microsecond, 1.6 microsecond, 1.8 microsecond. Reset. This is reset. 1 0 here. After that 1 1. Another. After 400. I'm a character. 400 or 300. You can say 300 approximately or 400 pakka. Okay. Here 300, maybe 350 nanosecond. Here in clock 0, 1. These are reset condition. Okay. H0, H logic. This is H3, H0 logic, H3 logic. 3 H logic. Present state output. Here 0, 1, 2, 3, 4, 0, 1, 2. Here 3, 2, 3, 1, 2, 3, 2, 3 up and down. So here up to here 0 up to 500 nanosecond. Okay, then up to 600 nanosecond to 1, and up to 800 nanosecond, 1 microsecond here. This one, so up to 1.2 here work, up to 1.4 here, sorry, here, cross, up to 1.6 microsecond here, like this, so on. Example 5, 2-bit up down counter with the active low enable and synchronous reset SRE SET. State diagram. Clock is implied. State 0, state 1, state 2, state 3. Here up and down counter with the active low enable and synchronous reset. Okay. Reset here self SRN bar, here EN SRN all state itself, here S2 also save, S2 also enable SRN, here also enable SRN. Okay, this is this direction UPN enable SRN, UPN bar EN bar SRN. Okay, here EN UPN bar EN bar SRN. In S1 S2, S2 coming from S1 to S2, from S2 S3, S2 to S3 state UPN bar EN bar SRN. From S3 to S0 UPN bar EN bar SRN.